So in our third section, we talk about more application of that set theory, so more talk about that Venn diagram. Example 1, Rachel surveyed grade 12 students about how they communicated with their friends over the previous week. 66 called on a cell phone, 76 texted, 34 used social networking, 56 used a cell phone and texted, 18 called on a cell phone and used social networking, 19 texted and used a social networking, 12 used all three. Well, if you add that up, that is 281%, which is more than 100% of the people that could potentially be in any kind of class. Now, obviously, these numbers are a little bit skewed, except, for example, right now, this 34 should probably be about 86, I'm assuming, textings or IBM or whatever is happening right now would also be higher, and then the 66 would probably be non-existent. But anyways, it's just an example that helps us to work. Because this is being way over, it means that some of these percents are over top. So if we, and because we have three different options, we have cell phones, texting, and social networking. Cell phones, texting, and social networking. It means that there should be some overlap between each of them. In a question like this, it's always easiest to start at the end. 12% used all three. That's this. That's this intersection between all three circles, which means texting and using a social networking, this 19% here is talking about this entire intersection between texting and social networking. To find out what's just in this part, we'd have to take 19 and subtract that 12. So 7% just texted and social networking. And obviously now it's different, but we'll still use what we have. Same thing with this 18%. Calling on a cell phone and using social networking. Cell phone, social networking. And it's talking about the intersection. It's talking about this intersection right here. To find out what this would be, so I'm just going to fix that. We have to take 18 and subtract the 12. That's already part of it. Obviously, then it becomes 6. $56 cell phone and texting, again, and is talking about an intersection between cell phones and texting. 56, subtracting that 12. Should be 44. Now you don't need to show these because I'm hoping that you can either do them in your head or you can do them quickly on a calculator. Really, if you can just fill them in, that's fine with me. But I'm just showing them for our work. Now it doesn't really matter which one we start with, but since I kept on going from the bottom, I'll hit this 34% first. 34 use the social network. So that's saying that this entire circle here, social networking. 34. We have to subtract the parts that are already in it. So we just have to subtract the 6, subtract the 12, and subtract the 7. Which means there would be 9% that just sent Facebook Messenger calls. They didn't use a cell phone, they didn't text, they just used Facebook or Snapchat or Instagram or whatever. 76 texting, well, that's talking about this entire circle. And we have to subtract the relevant parts. So we have to subtract the 44, the 12, and the 7. And that comes out as 13. Last but not least, 66 using a cell phone. Let's see. We subtract the 44, subtract the 12, and subtract the 6. And we get 4% that just called their friends, actually talked to them. So that's all in all. If you add those things up, 4, 44, 13, 12, 6, 7, and 9, 12, 6, 7, and 9, it only is 95. Which therefore means 5% of people didn't want to talk to their friends over the weekend or over the week. They just literally talked to them at school. Maybe they got grounded. Maybe their cell phones were taken. But here is where it gets more complicated. Here is the entire formula. And it's actually not as hard as it looks. But we're going to talk about what each of these parts are. This is the number in A, union with B, union with C. So that's just saying, what's in all three circles? All three together. And A, not applicable. It's just talking about how many are in one circle. When I talk about A, B, C, I usually use A, B, then C, so top left, top right, and then center bottom. If you do it inverted, however works for you, but this is how I usually do it. But here's our first circle. Let's talk about everything in here. This one is everything in this one. So that'll be NB. And C is talking about everything in this circle. And A intersection with B. So that's talking about, in this case, this purple intersection. What is an A and B? Just like A and C, it's talking about what's in this entire intersection between this circle and this one. And this one, well, what's in this circle is what's in B and what's in C. This symbol is A intersection with B intersection with C. It's all about what's in just all three. So in this case, it was the 12% that used all three forms of communication. Now, if we use the numbers for this, the biggest thing is we couldn't have actually used this formula to do all of this. We had to actually use some common sense and some logic to fill in our here. Because it doesn't say anything about this 5% in here. We would be going in blind right here. Actually, no, actually it would work. Never mind. Number in A. So I'll explain that in a second. It says, how many are on the cell phone? Well, 66. How many texted? It was 76. And then it was social networking, which was 34. Now you subtract the intersection between A and B. So that's talking about How many are in the cell phone and texting? Subtract 56. Subtract cell phone and social networking. This one, it was 18. Cell phone and social networking. This one is texting and social networking. And that was 19%. Yeah, texting and social, 19. All three, you add. And it was 12. You plug all that into your calculator, comes out as 95. Which means that then we'd be able to determine that 5 would be left. 5 were grounded. 5% was grounded. So in a class of 20, that's one kid. But also doesn't make sense for a lot of these other percents because of all that, but it all works. All right, let's get into some of the stuff, some examples that are a little more convoluted. Again, we'll use the equation. This one, we're actually going to use it. It says 24 children have a dog, cat, and a bird. Or a bird, sorry. 13 have a dog, 13 have a cat, 13 have a bird. Now, we will just let's call dog A. And then we can use bird and cat as B and C. Make sense? So we can use the equation. As 14 have only a dog and a cat. 13 children have only a dog and a bird. 2 have only a cat and a bird. No child has 2 of each type. How many children have a cat, a dog, and a bird? That is our first question. How many have all 3? Which in this question is asking that. We don't know. So let's find out. We don't know. Actually, I'm just going to change my colors. I'm going to change this to red. That and. We don't know what that is. So we can fill in a lot of our information right here. And that's what we're going to do. Now 13 having a dog. So A is dog. And then we have B for bird, C for cat. We know that this entire circle has to add up to 13. Same thing with this one, same thing with this one. It says 4 children only have only a dog and a cat. So a dog and a cat, it means that they don't have a bird. So that's actually saying that that part right here, that is the intersection between dog and cat, but not including this intersection, which would include bird, is 4. 3 have only a dog and a bird. So dog and a bird, that's this. 2 have only a cat and bird. So it's not talking about this entire intersection here. It's just talking about just this part. No child has 2 of each type. Well, that's just kind of saying that it doesn't matter whether they have more than 1 dog or more than 1 cat. We still don't know how many have 1 of each. That's where our formula comes in. Now it says that 24 have a dog, a cat, and a bird. So that means that our entire union has to be 24. There'd be nothing on the outside. The question doesn't allow it. It says 24 have a dog, a cat, or a bird. Meaning we're only considering kids that have an animal. So technically we wouldn't need this box around it, but it's just to help keep everything nice and neat. Number that have a dog. Again, we'll use A means dog. So every single time I see A, I'll just put in B. So it says that 13 have a dog. Okay, so 13. How many for a bird? 13. Awesome. And cat, 13. We have to subtract the number in dog and bird. So dog and bird, though, is talking about this entire intersection. dog and bird, sorry, not that entire section, this one. This entire intersection here. My pen doesn't want to go nicely. This entire intersection right there, we don't know what that is. So we're going to have to be a little bit creative with it. This entire intersection can be notated as x plus 3. This entire intersection here. So I'm just going to change the color. Is whatever's in this triple intersection plus that one. Subtract. How about the number that have a dog and a cat? Dog and a cat is 4, but that's only, so dog and a cat. Dog and a cat, dog and a cat, dog and a cat. Well, that's talking about this one. Let's use purple here. Dog and cat is this intersection. So this entire intersection can be written as x plus 4. Now I'm going to use yellow for the last one. It says bird and cat. So bird and cat is talking about this entire intersection right here. Which means bird and cat will be x plus 2. And last but not least, the question or the formula says number in A, or dog and bird and cat. We don't know how many have a dog, bird, and cat. That's x. So now you have to pay attention here. We have to combine the like terms. 13 plus 13 plus 13 is 39. Okay? But then we have to subtract 3. So 36. Subtract 4. 32. Subtract 2 is 30. Here is the tricky part. I know it goes back to grade 9, but at the same time, a lot of people have difficulties with grade 9 for some reason. You have to subtract x, subtract x, subtract x, and add x. If you subtract x 3 times, you're at negative 3x. You then add one more x, you're at negative 2x. Now we can do grade 7. Subtract 30. Get negative 6 is negative 2x. Divide by negative 2. And for our answer to A, how many have a cat, dog, and a bird? 3. How many children have only one pet? Well, we're going to just have to go a little bit fancy with it. 13 subtract 3, subtract 3, subtract 4 is 3. So there's 3 people, 3 kids that only have a dog. If we apply the same thing here, subtract 3, subtract 3, subtract 2, 5. So there are 5 kids that just have bird. And 13 subtract 4, subtract 3, subtract 2 is 4. So 4 only have a cat. There are 12 kids that have only one of any type of pet. 3 that only have a dog, 5 only have a bird, 4 only have a cat, 12 only have one pet. Last one. We also don't need the equation for this, but the reason I show you this equation on this one is you have to be paying attention to these x's. Have to. It's going to be a lot of the questions that you're going to ask me. And that's where you're going to get it from. Our guidance counselor is planning schedule for 30 students. 16 students say they want to take French, 16 want to take Spanish, 11 want to take Latin. So those are our options. We have French, Spanish, and Latin. 5 say they want to take French and Latin. And of these, 3 want to take Spanish as well. 5 want only Latin, 8 want only Spanish. How many students want French only? Well, so the question is asking, what is that? In order for us to do this, we're going to need to fill in everything else. We know that 16, this entire circle here has to be 16. Same thing as this entire circle has to be 16. This entire circle has to be 11. So that doesn't really help us, so we're going to have to go with other information. We'll have to use a little bit of logical reasoning. 5 say they want to take French and Latin. So French and Latin would be this circle, or this intersection. Oh, but the next line helps us with the rest. 3 wanted to take Spanish as well. So if this entire intersection here has to be 5, and 3 want to take Spanish, that means 3 want to take all 3. Which means that there'd be 2 left that only want to take French and Latin. Now, it still doesn't help us find out how many just want French, because we have a whole bunch of other unknowns. 5 want only Latin. Oh, 5 want only Latin. Okay, that's easy. And 8 want only Spanish. So that'll be that part. The rest of it is really nice and easy. It says 11 want to take Latin. Well, if this entire circle has to be 11, and we already have 10 spots filled in, it means that 1 wants to take Latin and Spanish. We then have 16 wanting to take Spanish. Well, 12 spots are already taken up in this entire circle. We'd have to have 4 left. Actually, sorry, I'm just going to change my colors slightly. $11, that's 1. That'll be 4 because of this 16. Then, if this entire has to be 16, 16 subtract 6 is 10, subtract 3, 7. Oh. 7 want only French, sorry, not France. All right, that should be good. If you want to work on it using the formula, it's not too bad. If you want me to show you, just ask me. But have fun.